Hello. As there's been somewhat of a revival in steam rocket technology recently, I thought I'd take a shot at it myself. The previous version suffered badly from heat escaping the boiler into the upper stage, melting and distorting the plastics. So this version I'll reduce the contact between the two and build the upper out of fiberglass, which is more stable at high temperatures. The fiberglass turned out to be very easy to work with. After a few attempts, the mixing ratio isn't that important with polyurethane resin, as the resin is also dissolved in a solvent, which off gases, and it will become semi-hard even without the hardening agent. The important factor with this is to ensure a good proper wetting and lamination of the fiberglass. Turns out the easiest way to do that is to, once you've made a mold, you then bind it in a material, in this case duct tape, to apply an even pressure over the majority of it, and that I got very good results from. I used baking paper as a mold release for the fiberglass. You can also do molding on the inside of a shape and pack that void with paper or something, which will apply a reasonable pressure. I'm using an Arduino Nano for my flight computer with a bunch of sensors and a few big servos to actuate my valves and parachute. If you're going to use big servos with an Arduino, it's fine, but you do need to wire in a big fat capacitor to take up the surge load, otherwise it'll brown out and your sensors will stop communicating. Also, the radio communication module, these NRF24 modules are great, but I'd recommend getting an RF24 Nano first, with it all built in, then proving your code, and then trying to get these finicky communication modules to work. The base station is essentially the same as a rocket, except we're running two servos, one for the temperature and one for the pressure of the boiler. We also have a big red button to launch the rocket. Parachutes can be tricky, but I had an old umbrella lying around, the canopy of proved to be just the right size for the mass of the rocket. 90 degrees temperature. You want to press the big red button? Be ready to wince. At this point, I performed a few tests to gauge the thrust of the rocket.
Brilliant.
At about 10 atmospheres, we get 10 kilograms of thrust, and with the addition of a nozzle, with a ratio of 1 to 3, throat to neck, we get a remarkable improvement of 16 kilograms of thrust, merely by the way it accelerates the gas as it allows it to expand down its length. This test also proved that my thermal mitigation didn't work perfectly, as temperatures inside the flight computer bay reached 50 degrees, which an Arduino Nano can handle, but if I'd wanted to take the boiler to higher temperatures and pressures, it most certainly would have got beyond the point at which my sensors could handle. My knowledge of C++ is quite limited, but it does the job. Both microcontrollers send a wee string of numbers between each other, and at either end it can be modified. It does a little check to see that the numbers are any good, and it works on a sort of, it'll ignore the radio communication if it's just white noise. I also wrote all of the sensors so that every second or so they're reinitialized. So if there's any power loss or signal loss to them, they'll start working again. Same as on the base station. This is kind of necessary because when you've got this high pressure vessel at the other end of a field, you don't want to have any reason or temptation to go near it and turn it off and on again.
Okay.
Finally, we have the test launch.
Firing. In 3, 2, 1.
Two, one. Unfortunately, there are two fatal flaws with my rocket, which resulted in two launch failures. Number one, I didn't do a very good job at making the thrust come out of the rocket straight. I tried to correct this later on, but it didn't do much for it, and really what we should have is thrust vectoring So a computer will control the stability of the rocket. This would correct problem number 2. Number 2 is the drag of the rocket is very close to the center of mass. Normally what you do is you put big fins on the bottom of a rocket so that, much like an arrow, the weight of the vehicle is well in front of the aerodynamic forces which point the rocket in a straight direction. But my rocket, all the weight is in the boiler, and the boiler is very heavy at launch. It's a bit lighter in flight, but even when it's fully empty, the point of drag on the vehicle is only slightly behind the center of mass. So the rocket has no aerodynamic incentive to go in a straight line.